Georges Cuvier was the second pillar of the French evolution. The first, as we've already seen, was Lamarck. Like Lamarck, Cuvier is often portrayed as an inspiration for the later advent of Darwinism. Like Lamarck, Cuvier is thought to have put evolution into the air, allowing Darwin to think fruitfully, and by implication correctly, about evolution. Like Lamarck, the reputation of Georges Cuvier has suffered a bit from being viewed through this Darwin-centered lens. Cuvier, for example, is widely claimed to have not believed in evolution. This is far from the truth. He was an evolutionist. He just was not a Darwinian evolutionist. The most interesting thing about Cuvier, though, was that, like Lamarck, he was a vitalist, but of a quite different stripe. Whereas Lamarck was steeped in the language and thought of metaphysical vitalism, with its focus on vital forces and spinning up theoretical systems, Cuvier was a process vitalist. Furthermore, he was no theory spinner. He was a thoroughgoing empiricist. He believed in evidence, and that explanations had to account for evidence. By all accounts, Cuvier was a brilliant student who was captivated from a young age by natural history. He was a devotee of another influential Frenchman, the Comte de Buffon, Georges-Louis Leclerc. Buffon wrote epic works on natural history, which were consumed avidly by the young Cuvier. Buffon, Lamarck, and Cuvier all were affiliated with those royal gardens in Paris, the Jardin du Roi. After the Revolution, Lamarck's and Cuvier's careers carried over into the renamed Jardin des Plantes. The timeline is worth noting. Buffon directed the Jardin du Roi until the end of his life in 1788, 1 year before the outbreak of the French Revolution. Lamarck, his protégé, took over and, as we have seen, managed its transition to the more republican Jardin des Plantes, literally keeping his head throughout. Cuvier, for his part, joined the Jardin des Plantes as professor in 1802. By then, the revolution had consumed itself in flames, and Napoleon Bonaparte had risen to power. Cuvier was 33 years old at the time, and he was very much steeped in the politics of Napoleonic France. The careers of all three men spanned epic changes. Buffon was a royalist and was the embodiment of Enlightenment France. Lamarck was also an Enlightenment figure who tried to keep his head through the turmoil of the French Revolution. Cuvier, for his part, was far more conservative a thinker compared to Buffon and Lamarck. Most important to our discussion, the lifetimes of these three men span the transformation of vitalist philosophy from metaphysical to process vitalism. Lamarck was probably the last metaphysical vitalist. Cuvier was a thorough process vitalist. The distinction is germane to an understanding of the development of evolutionary thought. Cuvier was the founder of the modern fields of vertebrate paleontology and comparative anatomy. Cuvier's initial work was on mollusks, begun prior to his moving to Paris and the onset of his formal career. He explored the differences between different species of animals and made several important discoveries. He was the first, for example, to identify African and Indian elephants as separate species, and he identified fossils of what he called the Ohio animal as the extinct mastodon or woolly mammoth, distinct from the elephant. He also identified a Paraguayan fossil skeleton as the extinct ground sloth, Megatherium. Not only did he catalog the differences between animals, he also formulated schemes for explaining the differences. He also became interested in the implications of stratigraphy, the layering of sedimentary deposits, and the different animal fossils contained therein. Prior to Cuvier, fossils had been considered somewhat of a curiosity. For many centuries, it wasn't even clear what fossils were. Were they artifacts of some unknown geological process, or were they the remains of ancient animals? Cuvier transformed the study of fossils from a gentleman's hobby into a science. Key to this was his pioneering work on the stratigraphy of geological sediments in the Paris Basin, which encompassed a large swath of central France. This work he undertook in collaboration with his colleague and mentor, Alexander Brongniart. The sediments of the Paris Basin are well stratified. Cuvier and Brongniart recognized that the different strata represented a sequence of time. Because different strata contained different types of fossils, this meant that life could change with time. It could evolve, in a word. Because many of the fossils that he described had no counterpart among present-day animals, Cuvier was among the first naturalists to propose that species could go extinct. Cuvier also established that the fauna of different geological eras were characterized by the dominance of different types of animals. It's to Cuvier, for example, that we owe the designation of the different geological eras as the age of the fishes, the age of the amphibians, of reptiles, and the present-day age of the mammals. For his time, these were heretical statements. Species were supposed to represent eternal types. They were not supposed to come and go. By establishing that species changed through time, that species could go extinct, and that new species could arise, Cuvier would seem to meet all the criteria for being considered an evolutionist. Yet Cuvier usually is portrayed as opposing the idea of evolution. Why on earth should that be? Well, here's why. Cuvier was an inconvenient evolutionist. What we mean by that is that his models of evolution did not conform to the Darwinian idea that was to come. Cuvier predated Darwin by several decades, so judging him by his conformity to the Darwinian idea hardly seems fair. But to paraphrase Winston Churchill, history is written by victors, and so it is with evolutionism. Once Darwinism came to dominate the intellectual landscape, Cuvier could not be allowed to merely have an alternate view of evolution. Rather, he had to have a wrong view. This is transparently illogical, and it must be said, a bit revisionist. So it's important to know what Cuvier actually thought, without it being filtered through the Darwinian lens. Let's begin by comparing Cuvier with his fellow French evolutionist, Lamarck. One important point of departure was how Cuvier saw the basic organization of life. As we've seen, Lamarck was committed to the idea of the great chain of being, that is, a continual escalator over time of living things up a gradient of complexity, supplemented with ongoing instances of spontaneous generation. Cuvier rejected the notion of the great chain of being altogether. Rather, he saw animal life as being organized into 4 large categories, or embranchements, as he called them, which corresponded to 4 major body types. These were the vertebrates, which included the mammals, birds, reptiles, amphibians, and fishes; the articulata, which corresponded to the arthropods, so called because they too had articulated skeletons; the mollusks, that is, animals with muscular feet and shells; and the radiata, which included things like the echinoderms, coelenterate like jellyfish, and sea anemones, and so forth. Obviously, Cuvier's taxonomic categories are widely at variance with our modern understanding of animal taxonomy. The echinoderms and coelenterates are a universe apart from one another taxonomically, for example, and Cuvier was wrong to lump them together into the radiata. Nevertheless, Cuvier regarded his embranchements as logical types of organisms. There's no great chain of being in this scheme, nor is there any observable trend towards higher and higher complexity. And it's very important to note that Cuvier built his system on observable distinctions. Unlike Lamarck, Cuvier did not rely on some ineffable striving for complexity. Lamarck's scheme, in Cuvier's view, was tainted by his adherence to such ineffable vital forces. Another important point of difference between Lamarck and Cuvier was how animal life changed over time. Let's revisit what we might call the Lamarckian conception. In this idea, complexity, no matter how we define it, increases with the passage of time. If we plotted the two with respect to one another, we would get a line indicating gradual change, that is, a tendency over time towards greater and greater complexity. Cuvier thought there was very little evidence to support this claim, and it was one of the main points of difference he had with Lamarck. He brought many bits of evidence to this argument. One of the most famous involved specimens of mummified cats that he had brought back to France from Egypt during an archaeological expedition there, as part of Napoleon's military campaigns in Egypt. If Lamarck was correct, Cuvier reasoned, one should see some evidence of difference between these mummified cats from 6,000 years ago and present-day cats 6,000 years later. Cuvier could not see any observable difference between cats 6,000 years ago and cats today, and he worked hard to find differences. From this observation, Cuvier concluded that the Lamarckian idea of gradual change could not be correct. It's worthy of note that this was a truly scientific conclusion, based upon observation used to test a proposition. Cuvier's mummified cats were his way of illustrating what he considered was the correct evolutionary pattern. Let's come back to his sketch of the stratigraphy of the Paris Basin. These layers of different sediments represented a sequence of time, from older to younger sediments. Each distinctive layer within the series contained within it certain distinctive fossils that differentiated one sediment from another. The difference in distinctive fossils between strata represented an evolutionary change. Furthermore, the strong layering of these sediments represented abrupt changes in the composition of the biota over time. Cuvier called these abrupt changes catastrophes. His choice of this term is unfortunate and a little misleading because the word catastrophe is associated with violent change, and this was not Cuvier's meaning. He was simply using the word in its classic sense, which means to overturn. To Cuvier, then, the fossil record showed that evolution did not proceed gradually, but through a series of periods, each with its own distinctive biota, interspersed with relatively abrupt changes in conditions and biota. At each catastrophe, a new and distinctive biota would arise, which would persist until the next catastrophe. This pattern of evolutionary change is called catastrophism. Again, Cuvier did not just pull this idea out of a hat. Cuvier was a strong empiricist and based his conclusions on observation and evidence. His ideas, in fact, shape our modern understanding of the fossil record, which divides geological time into a number of distinct eras and periods, each characterized by distinctive fossils. Our understanding of Cuvier's evolutionary views are also muddied by a peculiar game over the meaning of the word evolution. The word's literal meaning is to unfold. Initially, the word evolution was applied to embryonic development, as in the adult form unfolding gradually during embryogenesis. When the word was co-opted to mean the transformation of life through time, it carried with it the implication for the gradual transformation of life. Lamarck thought transformation was gradual, as we've seen. So too did Darwin, as we shall see, although for a different reason. Cuvier, as we've seen, disagreed with the idea that evolution could be gradual. So in the strict sense of rejecting gradualism, one could say that Cuvier was anti-evolution, but that's being a little disingenuous. In the broader sense of the word, Cuvier emphatically was an evolutionist, He subscribed fully to the idea of the transformation of biota over time. He just didn't think that the transformation was gradual. This focuses our attention on the most important question about Cuvier. Why did he reject the notion of evolutionary gradualism? Why did he assert that evolution proceeded by long periods of stasis, little or no change in the prevailing fauna, punctuated by abrupt periods of transformation? At the heart of this question is a largely misunderstood concept, which Cuvier termed the conditions of existence. The misunderstanding comes from the term conditions of existence being mistranslated and misconstrued as conditions for existence. Charles Darwin himself is largely to blame for this. The difference in wording is slight, but the difference in meaning is immense. Conditions for existence is an environmental property. It implies the adaptation of an organism to a particular environment. Conditions of existence implies something much different, a property of an organism, not its environment. Cuvier derived this concept from another fundamental principle he developed known as the correlation of parts. Let's take each in turn. Cuvier's concept of conditions of existence is derived from the process vitalism that we outlined a couple of episodes ago. According to Cuvier, every organism had to be able to function well. And to do so, all parts of an organism had to exist in a particular relationship to every other part. If this sounds familiar, it should be. It is the concept of the many little lives that was articulated by one of the pioneers of process vitalism, Théophile de Bourdieu. Just as the many little lives composing an organism had to engage in an ongoing process of negotiation and mutual accommodation with one another to survive, so too, Cuvier thought, did the multiple parts of an organism. Different types of organisms would achieve their conditions of existence in different ways. So, for example, the teeth of an herbivore, like this fossil Apatosaurus, consisted of peg-like leaning teeth and flat teeth to grind the ingested plant material. Because being an herbivore involved gathering plant material and grinding it up, these types of teeth met the conditions of existence for the herbivorous Apatosaurus. In contrast, the teeth of a predator, like this Tyrannosaurus, had to be sharp and capable of impaling struggling prey. Having sharp teeth, therefore, met the conditions of existence for the carnivorous Tyrannosaurus. The conditions of existence also disallowed certain combinations of parts. If, for example, one put a predator's teeth into the mouth of an herbivore, the conditions of existence for being an herbivore would not be met, and such an organism would not be a viable organism. Similarly, if one put an herbivore's teeth into the mouth of a predator, the conditions of existence for being a predator would likewise not be met. Existing organisms were ones in which the conditions of existence were met. In turn, organisms in which the conditions of existence were not met would not be feasible organisms, and these would not exist. This sounds like a fairly tautological idea. So, is conditions of existence just another way of saying that whatever is, is? That's not giving Cuvier nearly enough credit, however. Cuvier was among the first scientists to practice what we might call quantitative anatomy. Prior to Cuvier, anatomy was primarily a descriptive science. Cuvier combined description with quantitative measurements of the sizes of fossil bones. Out of this came a set of quantitative relationships between the different bones of an animal's skeleton. This he called the correlation of parts. He noticed that the correlation of parts of some types of organisms, like predators, were different from the correlation of parts of other animals, like herbivores. Cuvier's concept of conditions for existence was therefore derived from sound empirical data, his correlation of parts. This is not something he just made up out of thin air, and he interpreted his data in light of the cutting-edge process vitalism of his day. So, does Cuvier deserve better than to be considered just a wrong-headed footnote to Darwin? Both the evidence and a full understanding of Cuvier's thought points to the answer being emphatically yes, he deserves better. For one thing, Cuvier's catastrophism seems vindicated in hindsight by the realization that the history of life on Earth has indeed been punctuated by catastrophic episodes of mass extinction and species turnover. The most famous of these has been the mass extinction at the end of the Cretaceous, when an asteroid impact brought about a massive change of climate, which ultimately exterminated the dinosaurs from the face of the Earth. The mass extinction at the end of the Permian was even more devastating, and this too seems to have been precipitated by some type of cataclysmic event. And the standard presentation of the history of life on Earth as eras divided into discrete periods would seem to comport well with Cuvier's catastrophist viewpoint. Cuvier's thinking was also motivated by extensive observation and analysis of data, and in this he was much more solidly grounded in empirical evidence than was Lamarck before him, or, for that matter, Darwin after him. Cuvier also had a coherent explanation for the long periods of the constancy of fauna he observed in the fossil record. According to his conditions of existence idea, the coherent organism, once all the mutual accommodations of the parts were worked out, would be very resistant to change. Once an organismal lineage had attained the necessary conditions of existence, the tendency would be not to change, because any change would be a departure from the optimized conditions of existence and would produce an unfit organism. So strong was this adherence to the conditions of existence that it would take literally a cataclysm to disrupt it. After a catastrophe, once life had reorganized itself around new conditions of existence, these too would persist with similar resistance to change. So it should be very clear that Cuvier was an evolutionist by our modern understanding of the term. It should also be very clear that Cuvier was not a Darwinian evolutionist, but had a radically different idea of how species transformed over time. Thanks for watching. If you enjoyed this video, you might also be interested in my books, including my latest, Purpose and Desire, which is the inspiration for this series on evolution. If you want to find out more about me, you can visit my website. There's lots there, including information about my online courses. Have a look at some free sample videos from these courses. You might be interested in learning more. To see the next video in the series, or to go back to the evolution playlist, you can click here. Finally, please consider subscribing to my YouTube channel by clicking here. You'll get regular updates that way. Again, thanks for watching.